Hello students, in this video we are continuing our discussion of Chapter 4, Modeling Examples, by taking a look at this example from the textbook on page 117, the diet example. Here, a company, Health and Fitness Center, operates a morning fitness program for senior citizens. The program includes exercise, swimming, blah, blah, blah. And they want to develop a healthy breakfast that will be high in calories, calcium, protein, fiber, but low in fat and cholesterol. And, of course, to minimize cost. Right there, so we're going to develop a model that will minimize our cost of producing the most optimal breakfast using these 10 decision variables with these 3, 4, 5, 6, 7 different constraints. So we're going to look at this, we're going to keep in reference to this table. There's our decision variables, 10 decision variables, each one of these. So the question is, how much bran cereal, how much bacon or milk or orange juice do we use to create the most optimal breakfast that will meet these requirements as well as minimizing cost. What we're going to do is we're going to minimize this. Or actually, is this better? This is available in the PowerPoint. And that might be a better look at that. And let's bring up our Excel sheet. We have this one available as well. And let's go like that. So this is a diet example. It's minimization, so we're going to put cost there, and we can see our cost. Our cost is so much per cup or slice or egg or whatever we have. So X1, brown cereal X1, dry cereal X2, go forward here. Wheat toast per slice is X10. So we have 0.18, 0.22, 0.1, 0.12, 0.1, X6, 0.09, 0.4, 0.16, 0.5, and 0.7. Orange juice, quite expensive. There we go. Making sure we got all those numbers correct. And then, oops, I have the constraints listed here. This is basically in this section here. Breakfast to include at least 420 calories. So we're going to put the inequality signs first and the right-hand side. So the breakfast has to include at least 420 calories, so that's greater than and equal to. We need to feed, we need to have some calories in our breakfast. That's our calcium constraint. Our iron constraint is the same sign, and it's 5 milligrams of iron. 400 milligrams. These are all the same inequalities, greater than and equal to, representing at least, and that's calcium. Then we have the constraint, just looking at this, we have 20 grams of protein, 12 grams of fiber, and then it says, and must have no more than 20 grams of fat. So that's the less than equal sign. That's our fat constraint, and same thing with cholesterol. We need to watch our cholesterol. 30 milligrams. So now, all we have to do is kind of transpose these numbers. These numbers going down for calories, going across in our Excel spreadsheet here. So we have 90, 110, 100, 90, 75, 65, 100, 120, and 65. Iron constraint is that other column there, the middle column. 6, 4, 2, 3, 1, 0, 1, 0, 0, and 1. We have 5 milligrams of iron needed. Calcium, 400 milligrams of calcium. 20, 40, 12, 8, 30, 30, and then 26. What is... That must be orange juice, X8. Oh, milk. Oh, of course, talking about calcium. Sorry. It's kind of interesting. Protein, 3, 4, 5, 6, 7, 2, 1, 9 grams of protein and a cup of milk. And then 1 and 3. Fiber. Find the right fiber column. We have up to, or we need 12 or more grams of fiber. 2, 3, 4, 0, 0, 1, 0, 0, and 3. Fat, no more than 20 grams of fat. So no fat in brown cereal, a little bit in dry cereal. 5 grams of fat in an egg. Oops, egg is X5. Oops. Got to make sure we enter these values right. 3, 0, 4, 0, and 1. And then good old cholesterol. We need to watch our cholesterol. Doesn't look like anything has cholesterol except for when we get down to eggs. 270 milligrams of cholesterol. And what? Cholesterol, we can only have 30 milligrams. So it doesn't look like we're going to get an egg. 8, 0, 12, 0, and 0. There we go. Making sure those numbers make sense, are correct. So some of these constraints, this is a minimization question. Some of these constraints are greater than and equal to. Some of them, 2 of them are less than and equal to. So once again, in any question, it doesn't matter if it's a minimization or maximization question, the constraints that show less than and equal to, if there's any left over, it will be defined as a slack. In any constraints that are greater than and equal to, any leftover is going to be defined as a surplus. So let's go and create the solver for this. We're going to minimize total cost. Click on minimizing by changing variables in the production for X1 down to X10. And now we have to add the 7 constraints we have. Keeping in mind that we have to make sure we enter the right inequality. So it's always the usage. This is greater than what we have available. Greater than and equal to what we have available. Keep going through this, making sure we don't skip any or get them mixed up. So we have the 9, so now 10. Protein, what we have, what we're going to use, has to be greater than what we have available. With fiber, good old fiber. And now fat. Less than equal what we have available. And one more. Cholesterol, less than what we have available. We click OK for the last one. Minimization, simplex, and we can solve. Solver found a solution. There it is. There's our optimal solution. Right there. Doesn't look like they're going to be getting much. Basically, they're going to have, let's minimize this so we can find out what they're getting here. 1.025 cups of oatmeal. No eggs, as we saw. No bacon. They get a little bit of milk. 1.241 cups of milk. And, oh good, they get some wheat toast. They get 2.975 slices of wheat toast, so almost 3. If we do that, our cost will be 50 cents, $0.509, $50.9 per breakfast. So we'll notice that we have some constraints. Remember the inequality that's greater than, so these ones here, it's going to be a negative value. So those are going to then, these are going to be known as surplus. The binding constraints, there's only 2 binding or 3 binding constraints here. These ones here are binding. So calories, there's no left over. Calcium, nothing left over. And fiber, nothing left over. we could only use up to 20 grams of fat. We only use 10. For cholesterol, they said no more than 30. We used about half of that. And the same thing there. They wanted at least 20 grams of protein. We used more. We used 25. So that's good. The minimum amount was 20, so forth. So there's some binding constraints, some non-binding constraints. Slack and surplus would be defined there. And then we could, we know our optimal solution. We also could, I didn't, but we could have created that sensitivity and answer report. And then we could look at shadow prices and changing the constraints as well, or the objective function. But that's a good example of kind of a straightforward modeling example.